I'm Jack Gardner. I'm going to show you how to find the right soil for your need in some of the most dangerous places on earth. I'm going to help you build your understanding of soil classification and introduce index laboratory tests used to classify soil according to USCS. Join me on my adventure as we explore the visual manual methods, grain size analysis, and Atterberg limits.
Here we are in the wilderness of eastern Pennsylvania, on a high location on College Hill. Some soils don't need to be sent to a lab to be classified. Gravel and sand-sized soils can be roughly estimated using the human eye. This is what we call the visual manual method. So the three main steps we're going to follow are first determining the predominant grain size of the soil, then figuring out a group name and symbol, and then also just throwing on some random descriptors like color, odor, texture. Some soil sizes are too small to be determined using your eye. We found this soil sample here on the Bushkill River in Easton, and lucky for me, I got myself some field sieves, so we're going to do some grain size analysis. By taking this soil and running it through the different size sieves, we'll be able to figure out the predominant grain size. As you can see, we've taken our soil sample from the field and put them in this here stack of sieves. Now we're going to take these sieves and put them in our little rotor shift right here. Turn this bad boy on and separate the grain sizes.
Based on the data obtained from our analysis using the rotor sift, we can use the USCS soil classification chart for coarse grained soils to find our group name and number. The CEs revealed that we have more sand than gravel, fewer than 5% fines, CU equal to 7, CC equal to 2, which tells us we have an SW soil. CC and CU are ratios of particle size based on the percentage by mass in a sample. Since there's less than 15% gravel, we've determined that we've analyzed well-graded sand.
Whoa! Here we have what looks like maybe a clay. Now I am unable to use the visual manual method to determine this for sure, so we're going to have to take a sample of this back to the lab. Here we will complete the Atterberg limit tests. This involves tests for plasticity and liquid limit. With results of these, we'll be able to determine for sure what kind of classification this here soil is. So the first thing we will do for the Atterberg limit test is use this here Casa-Grande cup to determine the liquid limit of the soil. Now we've taken our clay and put it inside the Casa-Grande cup, spacing the soil about half an inch down the middle. We will now determine how many taps it takes to close this gap, using this crank on the side, equally spaced apart.
Eventually.
So we determined that it has taken 27 taps to close this gap. We will complete this test several more times with different water content and our clay to get a more accurate range for our liquid limit. To test the plastic limit of the clay, we have used a hairdryer to remove a specified amount of moisture content. We will now take the clay, place it on a glass plate, and begin to roll it into 1/8 of an inch threads. If the clay cracks at 1/8 of an inch threads, we'll know the clay is at its water content of the plastic limit. So after completing the plastic and liquid limit tests, we have weighed our samples and then placed them in the oven to remove water weight. Now that the samples have been dried out, we will take our samples and weigh them once again. We will then compare these weights to determine the water content of the soil at the liquid and plastic limits.
Based on the data obtained from our analysis using Atterberg limit tests in combination with grain size analysis, we can again use a USCS soil classification chart for fine grained soils to find our group name and number. The test revealed that we had a liquid limit less than 50, which tells us the group symbol is CL. Particle sizes were found to be between 15 and 30% passing 200 sieve, and a percentage sand greater than a percentage of gravel, which tells us we have a lean clay with sand. That's all for this week's episode of Man vs. Soil. Join us next week as we hunt fatty lean clays.